Hi guys, today we're working on parts of a hyperbola. We will learn what every single part is called so we can start writing equations and coming up with equations of asymptotes. That's the first word I want to start out with. So remember the definition of asymptote is a line that is not there, that's why it's dotted. So the asymptote is a line that your graph approaches but will never touch or cross. So notice that here in this hyperbola, we have this asymptote and this asymptote. So we have two. Notice that it approaches but will never touch or cross. So that's our first word right there, asymptote, right there. Okay, this one and this one. So one is going down, so it's just a regular line, but it's a line with negative slope, and we have the line with positive slope. Okay, we will write equations of asymptotes later. Okay, so the orientation where the hyperbola opens, that's very important too. So this one in particular is a vertical orientation hyperbola. So vertical, because it opens up and down. Okay, we all know this is the center. So we have the vertex. And this is the other one. We also have the covertex. So notice that the covertex, or the covertices, covertex, one vertex, two vertices. So notice that the covertex is not on the graph. So everything that is dotted is just there for your reference. It's not part of the graph. What's really part of the graph is just this right here. So it's the smiley face and the sad face. This is what your graph is. Everything else is there just for reference. So here we go. The vertex is on the graph. The covertex will not be. So one vertex, two vertices, one covertex, two covertices. Just like what we did with the ellipse, we also have the major and minor axes, but they're called differently on the hyperbola. So right there, not connecting. So the distance between the vertex and the other vertex, so the distance between the two vertices is called transverse axis. So right there in blue is our transverse axis. So now from one covertex to the other covertex is the conjugate. The distance from the center to the vertex is A. Same thing from the ellipse. And the distance from the center to B, yeah, I messed up. So the distance from the center to the covertex is B. Okay, right there. So A and B. Now the other example we have is a hyperbola, but it opens sideways. So again, what I'm highlighting here, that's the graph. Everything else is there just for reference. So this hyperbola opens side to side and is called horizontal orientation hyperbola or a horizontal hyperbola. And I'll pick up the pace here a little bit. So this one is the center, like the other one. And the vertex is on the graph. So the vertex is on the graph. The co-vertices are not on the graph. Here we have our two asymptotes. With positive and negative slope. So the transverse axis goes from one vertex to the other. So right there in blue is the transverse axis. And the distance from one covertex to the other, that's the conjugate axis. The distance from the center to the vertex is A, just like the ellipse, and the distance from the center to the covertex is B. All right, those are all the parts. See you later.